I'm recording this, so if you shout out answers, you'll be recorded, you'll be up on YouTube, and then some guy in India will be asking why you're yelling stupid stuff. So let's go ahead and get started. We're going to do problem number 100 in chapter 9. This is a child with a sled, and they slide down a hill and collide at some velocity. So we'll say V initial of their collision is 5.6 meters per second. And they collide into a stationary sled that is identical to the child's sled. So V initial of the child and their sled, and then V initial of just the sled, we'll say, is equal to 0 meters per second. The child is launched forward at the same speed, leaving behind the two sleds that lock together and slide forward more slowly. What is the speed of the two sleds after this collision? Okay. So final velocity of the child, and that's just the child, so that is, they tell us 5.6 meters per second. And they want the velocity final of the sleds equals what? Okay. How do I do this? What's chapter 9 all about? What's even the topic? Momentum. So I need to keep in mind momentum. What do we know about momentum before a collision and momentum after a collision? They're equal. So P initial equals P final. You always have the same amount of P. What is momentum? What's the equation for it? Just in general. P equals mv. P equals mv. Momentum is mass times velocity. Equation, we should just memorize that flat out. In the initial situation, I've got this kid standing up on a sled because they're an idiot. And then I've got this other sled. If I'm working with momentum, I need to know the mass and the velocity of every single thing in my system, both initially and finally. Initially, I have this kid, mass of the child, whatever that is, we don't know. I have the initial velocity of the child and the sled. I know what that is. That's 5.6 meters per second. I have the mass of the sled. And then I also have this other sled over here. So I have the mass of that sled, whatever that is. And then I have the initial velocity of just the sled. What's the initial velocity of just the sled? 0, because it's sitting there at rest. So this kid is moving forward at the velocity of the child plus the sled, and then the velocity of the sled that's just standing alone. Final situation. What happens to the sleds after I have this collision? What does it tell you in the problem? The problem, it tells us child is launched forward at the same speed, so this child's going to go flying. V final of just the child is going to be 5.6 meters per second. Leaving behind the two sleds that lock together and slide forward more slowly. So we have these two sleds now, and they've crashed into each other. The child is no longer on the sleds. So I have mass of the sled plus mass of the sled. I have two of them stacked on top of each other. And they're going to go sliding off at some V final of the sleds. So what I need to know in every single part of the problem is the mass and the velocity, because that lets me get momentums. So let's take stock. I have mass and I have velocity initially for the child. I have mass and velocity initially for the sled that's sitting at rest. I have mass and velocity of the sleds sliding off. I have velocity of the child. What's the mass of the child? Does the mass of the child change? No. Unless they go flying really fast and they vomit, we're going to assume that they don't. So that's just going to be mass of the child, whatever that is. What am I trying to find? Which one of those variables? V final of the sleds. This is what I'm looking for. Always good to kind of take stock once you've written everything down of what you're looking for. So let's write down the conservation of momentum for this problem based on all these things that we got out of this these pictures. Initial velocity, so the initial situation. I have the mass of the child times the initial velocity of the child plus the sled. Right, that's the kid riding on the sled and they're going along. Okay. Plus the mass of the sled times the velocity initial of the child and the sled. Because the child's sitting on the sled, so the sled has that momentum as well. So I have MC times Vox plus MS times Vox. So that's my initial momentum. I don't need to include the momentum of just the sled. Why don't I need to include this? It'll become 0 because the velocity is 0. So it has no contribution to the overall momentum. Now this has to be equal to the final momentum. Final momentum, I have the mass of the sled plus the mass of the sled. That's the total mass of the two sleds combined times the velocity final of the sled. That's what I'm looking for. Plus the mass of the child times the final velocity of the child. Yeah. Yes, question.
But is the child gonna like step off the sled? Why do we need to count it as for the final velocity?
Overall system is everything that's moving. So because the child was on the sleds, just because they've been launched off, they're still part of the overall system of momentum that you have. It's all still. This is what we have. What do I need to solve for? V final of the sled. So I need to get V final of the sled all by itself. What's the first step to do that? Let's subtract this from both sides. Mass child to V final child. Subtract that from both sides. Minus mass child times V final child. So I have mass child times V initial child and sled plus mass sled times V initial child and sled equals MS plus MS. It's 2 mass of the sleds times V final of the sled. Didn't subtract off. Rid of that very quickly. Make sure that we subtract this. So minus my mass of the child times the velocity final of the child. That's got to be equal to 2 ms times V final of the sled. Then what do I do next to get VFS by itself? Divide both sides by 2 mass of the sled. Divided by 2 mass of the sled. So I have MC times V initial child and sled plus mass of the sled times V initial child sled minus mass of the child, bless you, times V final child, bless you, times 2 mass of the sled equals mass or equals V final of the sled. My big giant equation. Okay. Do I know any numbers in this problem? Did they give us any numbers? I know. Okay, so I don't know the mass of the child. Stays blank. V initial of the child plus the sled? 5.6. Okay. Plus the mass of the sled. I don't know that. V initial of the child and the sled. Do I know what that is? That's 5.6. Okay. Minus mass of the child. Still don't know what that is. Do I know the final velocity of the child? What's that? 5.6. all divided by 2 times the mass of the sled. And I don't know the mass of the sled, equals VFS. How many variables do I not know? I don't know the mass of the child. I don't know the mass of the sled. I don't know the V final of the sled. How is this going to work?
The MC times 5.6 cancel out.
MC times 5.6
Minus
minus MC times 5.6. So those two cancel each other out. That's great. That makes this easier. So those two subtract out, and I have mass of the sled times 5.6 divided by 2 times mass of the sled equals V final of the sled. Now, I'll admit to you, when I was solving this last night, making sure that I knew how to do it, I got it to this step, and I was like, oh crap, I did something wrong. I looked at the instructor's solution manual to find out what my mistake was, and the instructor's solution manual, it just gave me the answer. So I was like, oh shit, I can't figure this out. I don't know what I'm doing. I'm a horrible physics teacher. What's going on? And then I noticed, oh, MC times 5.6 minus MC times 5.6. Those cancel out. Great. But then I still have MS. MS times 5.6 divided by 2 times MS equals VFS. I'm panicking. I don't know how to do this problem. I don't know what MS is. Doesn't matter. Why? MS divided by MS. We just got rid of MS. Multiple sclerosis is no longer a thing. So 5.6 divided by 2 equals VFS. So VFS is equal to 2.8. And what are the units? Meters per second. There we go. Let's record this. If this was an elastic collision, what else is true? Lorena? Kinetic energy before is equal to kinetic energy final. And that will let you calculate even more things. This is where algebra gets really messy. But you just have to trust in the algebra. This is what you have to do for the in-class problem. In the in-class problem, they say, for the preceding problem, find the final speed of each sled for the case of an elastic collision. So if this collision was elastic, so kinetic energy is conserved as well. As requested by the class, like, subscribe, comment, hit that bell icon to get notified when there's a new video that posts. And I haven't even monetized this, so that makes no sense to encourage people to subscribe.